So that's all that we have to do for comparative static analysis. That's all it is. It's just first solving the model for all the endogenous variables expressed in terms of parameters and exogenous variables, and then checking all the signs of the partial derivatives. Okay. So let's go ahead and do this one. Notice this partial derivative, partial p star, partial a, is the derivative of p star with respect to a, holding b, c, and d constant. So what we're doing in comparative static analysis most of the time is we're just letting one parameter or exogenous variable change, holding the others constant. Okay. Now, if you have 2 or 3 parameters changing at the same time, then it's more of a mess. The simplest one to do is just when one parameter changes. Okay. So notice p star is a function of a, b, c, and d. Okay. Normally, you think of parameters as being fixed, and they are normally. But now, in comparative static analysis, what we're doing is we're letting one of the parameters change. So that's why it's comparative static. Okay. So the way you're to think about this is think of p star as being a function of these 4 parameters. We're thinking of a p star as being a function of those 4 parameters. So now things have changed. I mean, a, b, c, and d are really now thought to be variables, even though they're parameters. You're treating them mathematically as if they're variables. Okay. All right. So the function is this very simple function here, a plus c over b plus d. So let's go ahead and do the comparative static analysis. What is partial p star partial a? We can solve for it. All you do is take this expression and you take the partial derivative of that right-hand side with respect to a. So there are a couple of ways of doing this. The simplest way of doing it is this. Let's just rewrite this as 1 over b plus d. Let's put brackets. Times a plus c. And when you take the partial derivative of p star with respect to a, you're treating b and d and c as if they're constants. So what is partial p star partial a then? Anybody? Jonna?
Is it 1?
Not 1, but what, Jonna, what is the coefficient on a? Not 1, but what is the coefficient on a? What are you multiplying times a?
1 over b.
Yes, 1 over b plus d. I thought, Johnny, at first you just said 1.
I did it.
Okay, yeah. See, 1 over b plus d is just the coefficient on a. It's what you multiply times a. So, but 1 over b plus b and d are held constant. So this is all just one big constant when you're doing the differentiation. So it's just 1 over b plus d. Okay. That's the simplest way to do it. And notice you're treating c as a constant, so the derivative of c with respect to a, of course, is 0. So this second term right here is c over b plus d, but all these are just constants. So the derivative of that is just 0. So you get 1 over b plus d. Alternatively, you could have got the same answer using the chain rule. Let's just illustrate that. Suppose you didn't see that, and you just used the chain rule. Go back to this expression right here. What is the derivative of the numerator with respect to a? Jonna? Now, what is the derivative of the numerator with respect to a?
Are we looking at a plus c over b plus
Yes,
c?
yes, yes.
Derivative of the numerator is
With respect to a. 1. It's the answer you gave before, 1. So you were just anticipating my next question. The derivative of this numerator with respect to a is just 1. Okay. And if we're using the quotient rule, you take the derivative of the numerator times the denominator. The denominator is just b plus d. Minus what? We're using the quotient rule, Diana. Okay, minus, you're right, but what is the rule? Yeah, the derivative of the denominator with respect to a. We're differentiating with respect to a. So what is the derivative of the denominator times the numerator? So what is the derivative of the denominator with respect to a? 0. Here's our denominator, b plus d. The derivative of that is, as Diana said, 0. Times the numerator. Just for the sake of completeness, I'll put that in. All over what? Yes, the denominator squared. So that's b plus d squared. See, the beauty of mathematics is no matter which way you do it, as long as you use a valid method, you'll get the same answer. So we better get the same answer we had before. So here we have b plus d over b plus d squared, which just gives us 1 over b plus d. We have a 0 here, so this just drops out. So this is our answer. 1 over b plus d. Same answer we got before. Okay. Now, I should have, I neglected to point out in this model, this supply and demand model, what are we assuming about all 4 of these parameters? What are our standard assumptions about A, B, C, and D? They're all positive. The assumptions we're making is that A, B, C, and D are all positive. So, under those assumptions, what is the sign of this derivative? Partial P star, partial A. Positive. Okay, B and D are both positive, so you've got a positive numerator, a positive denominator. This is positive. Okay. So, what does that mean? The fact that partial P star, partial A is positive means what? Exactly. As P star will move in the same direction as A, as the parameter A, yes. P star and A move in the same direction.